Okay, last time we started the discussion on functions. For example, and so we said functions are rules that assigns to every member of one set a unique member from another set. Okay, rules. What type of rules? I'll write it just to get things started. Example of a function. Let me see whether the side is correct. Yes, let's get it focused. Okay, example. Let f of x be equal to say x over x squared plus 1 for x belongs to R. I draw the part f from R to R. Let f of x, the rule is given, and this is domain is given. Domain is given, which the function, the rule is defined. Now this rule, and we also said input is the set, the domain is the set of all inputs. Inputs are mentioned here. This is the rule. F is the rule. Okay. When you input x, output is x over x squared plus 1. So we explained last time the functions as input-output machines. This is the diagram we had, input-output. So if you take the x as the input, this is like the machine. All the equipment inside, they work and spit out the output y. So we say if the rule is, if the machine, the rule that defines the function, we write y equals fx. When we write y equals fx, x is the input, y is the output. In other words, x is the input, f of x is the output. Y is equal to f of x. No, we said this is not fx. You know, f of x. It's a f. How do I read this? How do I read this? F of x. We read it as f of x. It's not multiplication. We also did last time. So when we write, let me write it here. Y equals f of x. Okay, x is the input, y is the output. How do you read this? F of x. Boring, no? Yes. But that's okay. Now, look at this and tell me the domain of this function. Domain is the set of all inputs. We are saying this is the rule, input-output rule. When you input x, you get output as x over x squared plus 1. For x belongs to R. See, inputs. X is the input, no? Here, x input. Input, y is the output. When you input x, the rule, it spits out input over input squared plus 1. That is the best way to understand it. And we are told that any real number can be taken as an input here for this function. X belongs, so it's mentioned here. Domain equals the set of all real numbers. R is the notation for set of all real numbers. Meaning you input a real number into this, you get a real number as the output also. Let us see. So what is f of 0? F of 0 is equal to, you have input 0. What is x now? 0. So wherever you see x, you put 0. Input 0. I need output f of 0. Find f of 0 means find the output when the input is 0. So 0 divided by 0 squared plus 1. 0 squared plus 1. 0 divided by 1 is 0. You don't write all this, just write 0, that's enough. What is f of 1? F of 1 is 1 over 1 squared plus 1. We don't normally write this step. 1 over 2. 1 squared is 1. 1 plus 1 is 2. Okay, that is in the denominator. So careful bookkeeping would be enough. What is f of minus 1? F of minus 1 is, well, now what is the input? Minus 1. Put minus 1 for x. Input x minus 1 over minus 1 squared plus 1. Minus 4, if you want, you can put the bracket also there. So you have top minus 1, negative 1 divided by here. What is it? Minus 1 squared is, if you square minus 1 times minus 1, plus 1, plus 1, plus 1 is 2. So the answer is minus. What is f of half? F of half for this function, put x equals half. Half over half squared plus 1. Okay, I'll write it here. Half over half squared. Now simplification. You must have sharpened your simplification weeks. Okay. So now, if you think you are weak, please work hard. Come and see us. We will try to help you. Half squared is half times half, no? Half squared is half. Square is half times half is 1 over 4 plus 1. Don't do silly mistakes. So here we have half divided by, this is, and if you take a common denominator, 5 over 4. How did I get that? Think about it. This is equal to half multiplied by 4 over 5. Half divided by 5 over 4. You can do it that way, or you can simply, this goes to the top, yeah. Okay, we'll do it. So now, this is 2. 2 over 5 is the answer. Okay, so that's enough for, what is the important thing here? When you input any real number, you get a real number as the output. So we did it for few. Domain is all real numbers. The set of all inputs given here. Now, it's sometimes the domain is not given. Just the rule is given. So, how do you figure out the domain in such cases? So, this is, if the domain ideally function is a rule, and we have to mention the domain, the set of all inputs that can be taken for this rule. For this rule, we have already said x belongs to R. So any real number is a valid input for this rule. So domain is the set of all inputs that is R there. If that is not given, how do we figure out the domain? If the domain is not mentioned, if the domain is not mentioned explicitly, if you don't know explicitly, don't read it. Yeah, if the domain is not mentioned explicitly, then we take read it and understand it. English we take the largest set. We take the largest. Largest set inside brackets say we are doing only real numbers. Largest set of real numbers. Largest set only real numbers, if you want to read that, on which on which largest set of real numbers on which the rule or the formula defining the rule makes sense. Makes sense. Makes sense. Makes sense. Makes sense. This domain is called two names for it. Some people call it the natural domain. You probably don't understand it from what I wrote. Natural domain, another name for it is implied domain. It's not mentioned explicitly, but it's implicit in the statement. Implied domain. And we simply just, they are the same. Natural domain or the implied domain. What do we mean by this? Take, for example, let us example, a function is given. F of x equals, consider f of x equals x squared plus 3x minus 1. Consider this. It's a rule. Only the rule is given. Let us say only the rule is given. Rule is given. Domain is not given. Only the rule is given. The domain is not given. Domain is not given. So what did we say? We use this. If the domain is not mentioned explicitly, meaning if the domain is not stated here, it's not given, what do we take as the domain? Then we take the largest set of real numbers on which the formula makes sense. Okay, good thing I read it again. Formula makes sense as the domain. As the domain. Largest set on which the formula makes sense. Makes sense. S-E-N-S-E. Makes sense as the rule එකට තේරුමක් තියෙන. Makes sense as the domain. Okay. Let us see. Makes sense as the domain. So here is a situation where just a rule is given. Only the rule is given, the domain is not given. So what do we take as the domain? We think largest subset of R on which or for which this rule makes sense. Meaning when you input a number, you get, when you input a real number, okay, whatever number here, you must get a output.
Excuse me, sir.
Yes.
Sir, I am Janika.
Yes.
Sir, that OTP code here, the student need to mark their attendance now. So I have already put in the chat box their OTP code, so they can mark their attendance.
Yes, students, please mark your attendance using the OTP code. Okay.
979038.
I forgot something. Pardon me?
979038, sir. OTP code is
979038. Students, I forgot something. Excuse me. Record session, sir. Yes. Oh, what time did you say it? 4:12. What time is it now? 4:16. 4 minutes ago. I forgot to record this, no? Okay. Same thing happened last time in another lecture, I think. I will start recording. Sorry.
Thank you, sir. Sorry for the disturbance, sir.
Oh, no, that's okay, Charika. Thank you. Let me get.
Recording in progress.
I'm sorry, students, I forgot to record, so I will just briefly mention what we did in the last 15 minutes. I was just recalling the definition of a function. Functions are rules that assigns to each real number of a given set a unique real number from another set. We wrote that definition down last time. I did some examples also. I'm taking another example here. Let f of x be x over x squared plus 1 for x belongs to R. Here, rule is functions are input-output rules. Here, for this rule, when you input x, output is input, meaning x over input squared, that is x squared plus 1. You can, here they are saying x belongs to R, meaning they are giving us the domain. What is the definition of the domain? Domain is the set of all inputs, allowed inputs. Allowed inputs are mentioned here. X is the input, no? Then they say for x belongs to R. This rule is valid for any real number x. So domain, you need to identify the domain. So that is this exercise. So that ends there, but I just computed f of 0. When you input 0, how to get the output? Input 1, input minus 1. I computed the output for those values. Okay. And then this is the important thing. Most of the time, just a rule is given. If the domain is not mentioned explicitly, වෙනමම domain එක කියලා නැත්තම් මේකෙදි වගේ here we are saying no, inputs are taken from R. So the domain is the set of all inputs. It's R. But if the domain is not mentioned explicitly, then we take the largest set of real numbers on which the rule makes sense as the domain. එතකොට domain එක කියලා ගන්නෙ ලොකුම set එක. Largest set on which ඒක මත ඕනම ලක්ෂයකදී ඕනම value එකකදී rule එකට තේරුමක් තියෙනවා කියන එක. Makes sense as the domain. That domain is called the natural domain or the implied domain. I took this example, f of x squared, f of x equals x squared plus 3x minus 1. Only the rule is given, the domain is not given. So what is the domain? Applying this, we think of the rule a little bit deeper. You input any real number, that is the largest set. No, for any function, we are considering only functions with domains as parts of real subsets of real numbers or the real number system itself. That is what happened here. Domain is R. But here also, if you input any real number, maybe 0, 1, square root 2, minus 5, whatever. When you input any real number, you get the output as a real number also. How do you get the output? Input squared. If this is a real number squared is a real number plus 3 times a real number. If you multiply a number by 3, again a real number by 3, it's a real number. Negative 1 is a real number. So when you input any real number, you get a real number as the output. So shall we say? So the rule makes sense for every real number x. If you input any real number, if you input any real number, you get a real number as the output. say input 5, if f of 5, I told you this bracket is not multiplication, we read it as f of x. If you input 5, f of 5 is 5 squared plus 3 times 5, 15 minus 1. 5 squared 25 plus 15, 40 minus 1, 39. If you input not only 5, input any real number, I explained it, output would be that real number squared plus 3 times that real number minus 1. It's also a real number. If you input any real number, then we you get a real number as the output. You get a real number as the output. So input-output rule makes sense. You get a real number as the output. So what is the conclusion? Therefore, what is the domain of that function? Domain of that function is here as an output. Therefore, the domain, just say domain, the domain of above f, domain of f is set of all real numbers. Any real number as the input would make sense. Now we go to a different example. Let f of x be 1 over x. Look at this rule. Only the rule is given. So what is the domain? Nothing else is said here. What is the domain of this function? There is, if you input any real number, output is 1 over that real number. Except one real number, all the other real numbers are okay as inputs. This rule does not make any sense if you input x equals 0. What is f of 0? F of 0 is 1 over 0. It is not defined. The rule doesn't make sense. When you input 0, you cannot get a real number as an output. So the rule doesn't make sense for x equals 0. So f of 0 is undefined. So the rules, when you work with rules, if there is a denominator, the places where the denominator, meaning the bottom, is equal to 0 are undefined places, undefined inputs for the function. This doesn't make any sense if x is equal to 0. So if you input 0, you cannot get an output because 1 over 0 is undefined. For any other real number, so domain is given by domain for this function, given by the set of all valid inputs. Largest set is given by R, given only by
Recording in progress.
One day I could write something. So put x equals to 2 as the input, f of 2, this is a separate thing. We have decided on the domain. This is just to show you that if you input any other real number, then you get a real number as the output. Input 2, f of 2 is 1 over 2. F of minus 2, f of minus 2, 1 over minus 2. Minus 1 over half. Minus sign can be written anywhere here. This is the minus half. Even if you put minus there, it's minus half. So we write it as minus half. So f of 0 is undefined. But for any positive value or for any negative value, this rule makes sense. Do you understand what we mean by a rule doesn't make sense? Given by x not equal to 0. So the domain as a set, we can write it as domain equals real numbers minus throw away 0 from the set of all real numbers. Another way to, if you don't like this, you can say using set notation. X belongs to R such that 2 dots x not equal to 0. That is another way to say that. All real. X belongs to R. What is X? Now we are saying X is a real number such that 2 dots or a vertical bar here indicates the conditions that are imposed on the variable X. X belongs to R. X not equal to 0 is the same. Or take all real numbers that are not equal to 0. So positive as well as negative. Positive real numbers and negative real numbers. Both are fine. But if you input 0, you are getting into trouble. Now, next example is, what is the, yes, we did the graph set now, otherwise I could have drawn the graph also. Now, let us go to next example. These are elementary examples too, but need to understand. Now, consider we don't have to write F all the time. We can use other letters like G, H, okay? But at the beginning, we shall use f of x. So consider f of x equals, or let f of x equals square root x. What is the domain of this function? What is the domain of this function? Domain? Input 0. Then square root of 0 is equal to 0. That's okay. Input 4. It is square root of 4. We told you it's equal to 2. Suppose input 3. Answer is square root of 3. It's 1.3 something, but square root 3 is square root 3. You don't get used to thinking of those as real numbers. Square root 2, square root 3 is 1.7 something. Sorry. Square root 2 is like 1.4 something. ... It's a decimal expansion never stops. It's an irrational number. But anyway, what we are trying to do is to understand the domain of this function. So if you input 0, you get a real number 0. Any positive number like 3, 4, any number for that matter, if you take any positive real number, we get square root as a real number. But what is f of minus 1? F of minus 1 would be square root of minus 1, negative 1. Square root of minus 1. Square root of minus 1 is not a real number. Square root, this is Remember we mentioned this as I, in fact, when we did quadratic equations. Square root of -1 is not a real number. So that is bad, because I want my functions to produce a real number when we input a real number. Now, so not only this, f of any negative number is not a real number. Now, those things are not there in the note. I have just said it. So, it's important for you to attend the class, okay? Otherwise, you run into few problems later, not only not understanding the subject matter, but also not being eligible to sit the end semester examination. So don't put you into that position. So participate when I ask questions. If you are okay, just answer and try to enjoy the learning. So f of -1 is not a real number. F of any negative number, any negative. Shall I write negative like that? Any negative number. Not only f of square root, f of -1, not only square root of -1, f of any negative number is not a real number. They are complex numbers, no? It's not a real number. So, but f of any positive number is square root of a positive number is a real number. Square root 0 is 0. So only bad values are negative numbers. For this, so the domain of f, after analyzing, domain of f is what? Given by, domain of f is given by x greater than or equal to 0. Domain of f is given by x greater than or equal to 0. This can be written as a set. As a set, it is x greater than or equal to 0 is the domain for that. As a set, domain of f equals x greater than or equal to 0. As a set, you can write it like this. X belongs to psi. X belongs to R. X is a real number. That's what it says. Real number such that it is greater than or equal to 0. Now, in the interval notation, if you visualize this on the number line, if 0 is here, 0, and this is the domain geometrically. That is an interval. You can write that as closed 0, infinity. So if you can get to this place, that's enough for now. This is a little bit of seeing this type of notations will make you comfortable when you move to upper level courses. Okay? Domain of f is that. Now, these are two typical type of examples. 1 over x, f of x equals 1 over x, domain is x not equal to 0. F of x is square root x, domain is x greater than or equal to 0. Okay? Now, next example. State the domains of the following functions. Find the domain or state the domains. Find the domain of f given by just to get used to different ways of writing. Domain of f or domain of f of x given by f of x equals x plus 1 over x minus 1 x plus 3. Find the domain of the function f given by this rule. If they have said x belongs to what here, then of course we don't have to worry. That is the domain. If they have said so. But as we said, we have to, in many situations, only the rule is given, not the domain. In such cases, we said, we take the domain to be the largest set of real numbers for which this rule makes sense. Meaning when you input a real number, you get the output also as a real number. Now 1 over x only had x equals 0 as a bad place, because 1 over 0 is undefined. Here also there is a denominator. Domain is given by bad. So let us say bad when this rule is bad when x minus 1 times x plus 3 equal to 0. If the bottom is equal to 0, rule is undefined. The rule is bad when this happens. Now solve this one. If we need solving of the equations, it's in the factored form. So we get x minus 1 equal to 0 or x plus 3 equal to 0. This is the same as this. This is the same as x is equal to 1 or x is equal to minus 3. So bad when x is equal to 1 or x is equal to minus 3. Any other value, input any other real number, then you get a real number divided by non-zero real number. And this is also non-zero because I'm taking x to be not equal to 1 and not equal to minus 3. If you do that, then there is a real number as an output. Rule makes sense except for these values. Therefore, the domain of f is given by domain of f is given by x not equal to plus 1 comma minus 3. Domain is given by x not equal to 1, x not equal to minus 3. Now, last example, and you will be doing some examples of this nature in your what are those sessions? Interactive sessions. Okay, sorry. It took a minute for me to. Now, last example, find the domain of this. Find the domain of the function given by, find the domain. First one, f of x equals square root of x minus 3. What is the domain of this function? There is a square root. Remember, when there is a square root, inside should not be negative. Therefore, we immediately say the domain is given by the domain is given by inside of the square root. That is x minus 3 greater than or equal to 0. Now you did solving of inequalities now. clear, simple inequalities. Just get the idea how to do it and understand it. You don't have to do big problems with big computations. What we want sometimes after you learn this, okay? After you learn this, most of this can be done much faster using a computer. So whether you can do big problems with big computations or not, it's not going to matter much now. What's important is to understand the concepts. So how to solve this simple inequality given by IE, that is Latin for IE, that is x greater than or equal to, take this minus 3 to the other side, or add plus 3 to both sides. That is the best way to explain it. But students like it when we say, when you take this number to the other side of an inequality or equality, sign changes. Minus 3 becomes plus. X greater than or equal to 3. Okay, so that is the domain of this function. That's enough. This can be written as a set. It can be written using interval notation also. Second one, f of, shall I write g of x? G of x equals square root of 2 minus 3x. What is the domain? Again, only the rule is given. Name of the rule now is g. Name of the function is g. So we can talk of g of x equals that. Domain is given by the domain of g, or just the domain is given by inside there's a square root now. Inside 2 minus 3x greater than or equal to 6. Otherwise you get a, if it is outside of this set of values, then you get a negative number inside for the whole thing. If we have a square root, you cannot, inside cannot be negative because it would not produce a real number. The domain is given by this, i.e. that is the domain as an inequality. Yes, I need to simplify this. You can take 2 to the other side. How do I solve that? You have done it. Okay, Monica. Just to make sure that you have this pre-calculus stuff, computations mastered. Okay, so how do you solve this inequality? Keep x on the left hand side and throw the other terms to the other side. This is the same as negative 3x bigger than or equal to negative 2. So to the other side, it becomes negative 2. Or the mathematical way of saying it is not throwing and stuff, add minus 2 to both sides. You get this. Now, to find x, you have to divide by a negative number. Minus 3 is negative. You want to divide by negative 3. Dividing by a negative number, inequality reverses. X bigger than or equal to, I have to divide by minus 3. This becomes less than or equal to minus 2 divided by minus 3. You understand it? Why inequality got reversed? Multiplication and division by a negative sign, negative number, reverses the inequality. Greater than or equal to becomes less than or equal to, i.e. x less than or equal to 2 over 3. Less than or equal to 2 over 3. On a number line, if you were to see it, just plot 2 over 3 less or equal to this place on closed interval. It is, minus infinity, comma, it's a closed interval. What I said was right, but you don't need. domain is given by this. So if you come up with this, full marks. If you are asked to write it in the interval notation, you have to do this also, next step also. Okay, now summary of how to find the domain of a function. Summary of how to find the domain of a function. What are the things to understand? Wait. Domain. If you have 1 over something, this denominator should not be 0. Okay. And if you have square root of something, make sure that inside the square root is greater than or equal to 0. Those are the two things to check. Those are the two things to check. When the domain is not explicitly mentioned, okay, in almost all types of applications that we encounter, it would be either there is a denominator or inside a square root. If you have 1 over something, bottom should not be 0. If you have square root of something, inside should be greater than or equal to 0, should not be negative. Okay, so that is what I did in the previous two problems. Now, so domain, set of all allowed inputs. Next we go to another concept, graph of a function. The title of the section is functions and their graphs. Graph of a function. Graph of a function. Last time we spent some time sketching graphs of equations. Graph of a function. The graph of a function f. Okay, later we abuse notation and talk about function f of x. We have already mentioned today also that f of x is the output. But instead of writing of a function f, name of the rule, people sometimes write function f of x. They mean the same thing. Okay, no worries. The graph of a function f is the graph of the equation. Is the graph. That's why we did graphs of equations earlier. Is the graph of the equation y equals f of x. Y equals f of x. Now, functions, a very abstract objects, rules. We try to visualize it using input-output machines. But now we are into a new concept, graph of a function. The graph of a function is the graph of this equation. This is the equation in x and y that lies in the xy plane. Graph of the equation is the collection of points satisfying x comma y, satisfying this equation. Graph of the equation y equals f of x. You might not understand when you read it in English. Okay, let us do an example, then everything will be clear. Example, sketch Wrong. Sketch. දල සටහනක් අඳින්න කියන එක. Draw a rough sketch. Sketch the graph is the graph. Sketch the graph of the function. Sketch the graph of the understanding what I said about graph.
Recording in progress.
Equals x squared. All you have to do is sketch the graph of y equals f of x. Y equals f of x is y equals, what is f of x? F of x is x squared. So this is the same as graph of this is the same as graph of a function කියන එක මොකද්ද? Same as the graph of y equals x squared. We did it last time. මේක domain එකක් කිව්වනම් හොඳයි. What is the domain? Domain x squared, any real number. So the graph exists for every value of x on the x-axis. This is same as a graph of this. What the graph will make it? We did it last time. Remember by drawing charts x and y. Okay, we had the positive for 0 and positive, few positive values and few negative values. And we got, I asked you to keep those shapes in your memory. You don't do these to get values, get 7 values and try to plot them and get the sketch of the graph. You simply draw like this, x, y. Recall from your memory the shape. Y equals x squared. Y equals x squared was this shape. Parabola touching the x-axis at the origin. Symmetric about the y-axis. It just touches at the origin. Now don't color like that, that's bad. What I'm trying to say is it's a parabola touching the x-axis at the origin. This is the graph of f. The graph of f of x equals x squared, function given by f of. So if you want to sketch the graph of this function, just make f of x equals y and make the plot. Here, of course, this is a graph that we sketched last time. That is why we did that last time. Not just to sketch the graphs of equations, but to get you to understand the concept of graph of a function. It sounds the same, no? Graph of an equation. Where that involves x and y. We know how to do them. We did some elementary shapes. This is not a semicircle, this is a parabola. It's a parabola, y equals x squared. So that's it. Now I can ask you to sketch graphs of various functions, because I did graphs of various equations last time. So we know the graph of the function f of x equals x squared. Look at this. When x equals 1, y equals 1. That is 1, 1 is a point on the graph. Minus 2, 4. This point. Minus 2, 4 is a point on the graph of that function. Not only those, we sketch the shape and you were asked to keep that in your memory. Graphs of functions. First one, so the graph of, what is the example? F of x equals x squared. Second one, yes, graph of
Recording in
function
progress.
f of x equals x cubed. Next example, the graph. And so, example, sketch the graphs of each of the following functions. Sketch the graphs. Sketch the graphs of each of the following functions. Each of the following functions. First one, f of x equals x. F of x equals x. What is the graph? How do you sketch the graph of the function given by f of x equals x? Sketch y equals f of x. Meaning y equals x. Go to the xy plane. Y equals x we sketched last time. Y equals x is 45 degrees. This line, this is the graph of f. Graph of f, or graph of f of x. The graph. The straight line. For every input, so in fact, the graph of f is the graph of this equation. I will come to that. It's just input-output pairs. When we say y equals fx, f of x is the output, x is the input. Meaning f of x is y, y is the output, x is the input. So when you sketch the graph of a function, what we are doing is we are sketching the set of points, input, output. Input-output pairs in the xy plane. Second one, f of x equals 1 over x. What is the graph of this function? The graph of f is the same as graph of y equals f of x. Of course, x must be in the domain of f, otherwise the rule is not defined. Y equals f of x, meaning y equals 1 over x. We sketched the graph of y equals 1 over x last time. Choosing points. It's a hyperbole. 2 branches. This shape should be kept in mind. පුළුවන්ද කරන්න? හිතේ තියාගන්න ඕනේ, yeah? So, I need to graph this equation. F of x equals 1. This is O. X, Y. If you need help, we have done it last time using the chart. Y equals 1 over x. Now so this is the graph of this piece and this piece. The graph of f or f of x, 1 over x. Sometimes people say graph of f of x. Whatever is asked, whichever way it is asked, all you have to do is sketch the graph of an equation. Here, you see that when x is equal to 0, no output. When x equals 1, output is 1. Here. But when x equals 0, no, x equals 0. This curve doesn't cut the y-axis. When x is equal to 0, no y value, undefined. We know. The graph of f is this. F graph of it's okay to say f of x equals 1. Then comes f of x equals, it makes you comfortable and confident when you know these shapes by heart. F of x equals x squared. How do I sketch the graph of that function? It's a good thing to find the domain because we know if x is not in the domain, this rule doesn't make sense. Or the domain of a function, when the domain is not mentioned, we take it to be the largest set on which the rule makes sense. This is like the top one. Again, domain, what is the domain here? Domain is given by x not equal to 0. Domain is given by x not equal to 0. See? X not equal to x equals 0 is the y-axis. Any point on the y-axis satisfies the x-coordinate equals 0. That's another way to say it. So, it doesn't cut the graph doesn't cut the y-axis, but it gets close in a sense here. 1 over x graph. As x gets bigger and bigger, y heights are getting closer and closer and smaller and smaller. There are some limit things that we can discuss. Just write down, try to sketch the graph of y equals 1 over x squared. It's like 1 over x. Did I do it last time? I haven't done it. So now add this also to your collection of known graphs. X, y. I'm doing it as a graph of a function. It's the same as graph of this equation where you write y in place of y instead of f of x. When I do that, we will change the shape like. That is the shape, symmetric about the y-axis. Y equals 1 over x squared. Like the chart we did for this, 1 over x, try to do a chart with x, 1 over x squared. You will see when you connect the dots, you will see this shape for y equals 1 over x squared. Then y equals, did I write y equals square root x? In sketch, na? Square we sketch after we came. Then fourth one, f of x equals square root x. Domain is x greater than or equal to 0. Remember? Graph is the graph of y equals square root x. We have done that last time. Okay? So, when you are asked to sketch the graph of this function, all you do is you draw the graph of this. Knowing these shapes will make you confident and comfortable as we move further in this course as well as in Mathematics 1 next semester. That is the graph of y equals square root x, meaning graph of y equals f of x. Another, so how many? 1, 2, 3, 4. 5. Fifth graph, f of x equals absolute value x. Sketch the graph of this function. So I need to sketch the graph of y equals f of x. Graph of f is the same as graph of this. This is the same as y f of x is absolute x. Need to sketch this. Absolute value x. We sketched it last time. That was not that fun. We met last Sunday. X, not Sunday, sorry. When did we meet? Saturday, no? Okay. How do I draw the graph of y equals absolute value of x? Remember, we said the definition of absolute value of x. You have done this, no? Absolute value of x is x if x greater than or equal to 0, negative x if x less than 0. So, we know we have drawn the shape. Goes through 0, y equals x for x positive. And then y equals minus x for, wait a minute, have a calculation. This is the graph of f of x equals absolute value x. Okay. Now, there are, so these 6 shapes, I want to do another one. Sixth one. Suppose if g of x is given by how do you sketch the graph of this function? G of x equals 2. So you need to sketch the graph of y equals g of x, meaning y equals 2. So what is the graph of this function? I should have put f of x just to, well, 2 is, y equals 2 is somewhere there, 1, 2. And for every input, for every x, y is equal to 2. When x equals 0, y is 2, x equals 1, y is 2, x equals any real number, y is 2. Domain of this function is also a constant function. Domain. This is an example of a example of a constant function. It doesn't change with x constant. Near the street there. Constant function. Another constant function is g of x equals 7. G of x equals square root 2. G of x equals negative half. If you just put g of x equals 2, domain is all real numbers. The rule says no, for 2. This is what happens geometrically. For every input, output remains at 2. For any input, output remains at 2. Constant function also, this case. Now, constant function, f of x equals, we did g of x equals 2. Constant function. Then, f of x equals x, we sketched. After that, f of x equals x, we sketched. Y equals f of x equals 1 over x. 1 over x squared. Square root x. X squared we did as the first example. That's why it's not there. Example. This is an example of a constant function. Did I miss anything? So now, next one is this the graph of a function? Next example. Is this the graph of a function? What is this? The circle that we drew last time. I asked you to keep those shapes in memory. Equation is x squared plus y squared equals 1. This is the circle. Centered at 0, 0 with radius 1. So, can this be the graph of a function? Can this be the graph of a function? Take x here, input x. How many outputs are there? There are here here? Two outputs. A function. If it is a function for one input, there is exactly one output. Different inputs may go to the same output, may produce the same output, but same input cannot, any input cannot produce two outputs. For this X, there are two outputs. How do you understand it geometrically? Draw a line, vertical line. This is known as vertical line test. There are vertical lines that cut the graph given in more than one place. Therefore, it is not a function. Is this the graph of a function? No. We can use the so-called vertical line test. Meaning graph of a function cannot be met by a vertical line more than once. More than once. Vertical line test. The graph of a function the graph of a function cannot cut or cannot meet or cut, cannot cut or cross. Cut, cross, meet, anything is okay. The graph of a function cannot cut any vertical line. See, that's later out. Vertical lines are lines parallel to the y-axis, Tamil speaking students. Cannot cut any vertical line more than once. More than once. This is not a graph of a function. Meaning, if you have a graph of a function, it is the input-output pairs. Now, for one input, there is only one output. So if you draw something like this. Suppose this is the x-axis, y-axis. Is this the graph of a function? Cannot be, because this line crosses the graph at 3 points. If there is, the graph of a function cannot meet any vertical line at most once. So this is not a graph of a function. No. Okay, let me This is not the graph of a function. How about this? Is this the graph of a function? Use vertical line test. Vertical line test. The graph of a function cannot cut any vertical line more than once. It may not cut, like in this one. Look at this. Is this a graph of a function? Any vertical line crosses the vertical lines. any vertical line crosses the graph at most once. At most once. More than cannot cut more than once. So it's the more than once is the same as more than one is the same as not more than once. Not more than. At most once. So 1 or 0. Y-axis. Y-axis. The graph of this function doesn't cut the y-axis. It's okay. But if it cuts a vertical line, any vertical line, not just the y-axis, any vertical line, when any vertical line is drawn, the graph can meet the vertical line exactly once. One point of intersection. One. Or none. But you cannot, if it has two or more intersections with the intersections, intersections with a curve like this, that curve is not the, you cannot say graph of a function. No, it looks like this. But there is a f of x whose graph looks like this. Vertical line test pass, we pass the vertical line test, now we know the shape is the shape of f of x equals 1 over x. Now, how is it? So vertical line test done. We didn't talk much about the range of a function. The set of all outputs, set of all inputs is called the domain. Okay. Now, before I forget, what do I forget? Yes. Piecewisely defined function. Piecewise functions. It's actually piecewisely defined functions. Piecewise function. Just example. Straight away go to an example. Let f of x be. Let f of x be x if x is less than 0. 2x if x is greater than 0. What is the domain of this function? Domain is given by x not equal to 0. What is f of 1? Domain is x not equal to 0. See, inputs are given. But 0 input is not in there as an input for any piece. There are two pieces. It's a rule. One rule with two pieces. The rule is if x is negative, output is x. If x is a positive number, output is twice the input. So depending on whether this is satisfied or this is not satisfied, we get the output using this formula or this formula. But when x is equal to 0, it has no meaning. F of 0 is undefined. We have not defined it. Undefined. F of 0 is undefined. What is f of 1? Yes, f of 1. How do you find f of 1? 1 is positive. So output is given by this formula. Piecewise functions. One function defined using two conditions. For positive numbers, twice the input is the output. For negative inputs, it's just the input. X as. So f of 1, 1 is positive, therefore it is 2 times 1. You have to use this rule. 2 times 1, which is equal to 2. What is f of minus 2? F of minus 2, if x is negative, f of x equals x. So what is f of minus 2? Can somebody put it in the chat? The answer. F of minus 2 for this function. It's a function, it's a rule. But rule splits into two pieces. So when an input is given, you have to first check whether it's positive or negative. If it is positive, take the top rule. F of x equals x, meaning output equals x. Take a positive number, output is 2x, meaning double the input. F of minus 2 for this one, yes, one student has given the answer. Minus 2, very good, very good. F of minus 2 is equal to minus 2 because f of x equals x when x is negative. Yes, negative 2. Sketch the graph of this function. We have done the graph of a piecewise function when we did absolute value x. It is a piecewise function, then the first piecewise function you come across. Sketch the graph. Sketch the graph of this f. Meaning, the graph of, it is the same as the graph of y equals f of x. Graph of f is the same as the graph of this. That is the definition. Same as the graph of y equals f of x. But f of x comes in two pieces. So what is y? Y is equal to, y is f of x, no, f of x is this. Y is equal to x. If x is negative, and 2x. If x is, 2x is, if x is positive. So I need to sketch the graph of this. So then just forget the condition, just draw the two graphs. Do you know how to draw y equals x? Y equals x. I ask you to keep that in your memory. So this is y equals x. Underneath y equals x. Y equals, the other one is y equals 2x. Draw that also. Y is equal to 2x. 2x, it also when x is 0, y is 0. No? 2x has a bigger slope. This is the graph of y equals 2x. Now, to sketch the graph of the function, I have to sketch this. No? Take a scissor and cut along the y-axis. Cut along the y-axis. Look, y equals x if x is negative. So up to this place. And a hole there. For x negative, y equals x. That is this part of the graph. Here, for x positive, 2x. That is that. Now take a scissor and cut along the y-axis. Both pictures. Throw away non-red parts. Keep the red pieces and bring them together. Bring them together. Meaning cut and paste. How is it going, students? Couldn't ask you anything. I was doing 0. There is a hole here, and 2x. Just imitate that. And then at 0, hole. Straight line with slope is y equals x. It's more steeper slope, y equals 2x at 0. So that is the graph of, this is the graph of f. The graph of this f. Graph of f or f of x doesn't matter. Graph of this function. If x is negative, it's x. If x is positive, output is 2x. Graphs are input-output relations, obeying what we stipulated at the beginning. So is this clear? Now, I want to try something. And this should have been given as a quiz. Test the graph of this exercise, these functions and graphs. If you understand it, okay, it will lay the foundation for rest of the mathematics courses, including the rest of this course. That is the funny thing. Let f of x be equal to 5 if x is less than 0. X squared if 0 less than x less than 2. X if 2 less than or equal to x, or x bigger than or equal to 2. Now answer these questions. It's a piecewise function. How many pieces are there? 3 pieces. Depending on the input. If it is a negative input, output is to be taken to be 5. If it is an input between 0 and 2, then output is f of x equals x squared. Do you see the 3 equations? F of x equals 5 if x less than 0. The other one is f of x equals x squared if 0 less than x less than 2. F of x equals x if 2 less than or equal to x. So 3 equations. 3 equations in one. Rather than writing f of x, we throw away these 2 and put a bracket. That is that. So how do I sketch the graph of this? Tell me this. So tell me this. What is f of minus 1? Put in the chat, please. F of minus 1. Negative 1. If you input -1 here, which page should I take? This or this or this? -1 here means x is negative. So output is 5. F of -1 is 5. Yes, I have an answer. Then, what is f of 1? F of 1, according to this rule, which is split into 3 pieces. Different inputs. For different inputs, we compute outputs using 3 different formulae. That is 1. Very good. F of 5 is 5. F of -1 is 5. F of 1 is between input. The input is x, no? 1. When the input is between 0 and 2, f of x equals x squared. So 1 squared. 1. What is f of 5? F of 5? Very good. F of 5 is 5 is input. Input is bigger than or equal to 2. So you have to use this rule. F of x equals x. Your x is bigger than or equal to 2. No? 5 is bigger than or equal to 2. So this is going to be 5. Sketch the graph of this function. Is there a way for me to see it? Sketch the graphs of these 3 functions. And then take the pieces, cut and paste. F of 5. F of x equals 5. Or y equals 5. Or f of x equals 5. X-axis, y-axis. 5, no, sorry. Y equals 5. So go to y-axis, mark the 5. For any input, it is 5. So you get a that is a graph of f of x equals 5. Then draw f of x equals x squared. Parabola. Y equals x squared or f of x equals x squared. Graph of f of x equals x squared. Same as that. Then graph of f of x equals x. X. Yeah, third one. To sketch the graph of this, I must sketch the graph of y equals 5, y equals x squared, y equals x, and then cut the pieces according to the conditions given. Domain is split into 3 pieces. Okay, from the first one, which part do we take? 5 for x negative. So 5 for x negative. So this is the, and there is a whole. Less than 5, no? sorry, less than 0. No? If x is less than 0, f of x is 5. This is the shape. And then for x between 0 and 2. And at 2, this is f of 2 is 4 or y is 4. Both holes. X squared, graph of x squared from 0 to 2, not equal to any place. So here, hole and a hole there. From x squared graph, I cut the piece between 0 and 2. Inputs are on the x-axis, outputs are on the y-axis. That you all know. Last one, f of x equals x. That is this one. But we are asked to take it only for x greater than or equal to 2. X, if 2 is here, x greater than or equal to 2 is this. Therefore, and it's a equal sign is also there. Dot, dark dot. That is the graph of f of x equals x. Here we are taking this only for x less than 0. From this, we get x less than 0. From this, we get x between 0 and 2. Then here, this graph is for x. We take from this graph x greater than or equal. Cut and paste. Required graph is f of x equal to 5. That is this red piece. 5. Let us say 5 is here. 1, 2, 3, 4, 5. Yeah, somewhere. That came from this. Cut and place it here. Then from 4 to what place? This is 5 now. 4 is somewhere here. 2. This is also a hole. And then, I need f of x equals x. If x is 2, this is f of x equals x, no, y equals x. If it is 2, greater than or equal to, so I want to get that point also. And where is it? This is 2, halfway. Dark dot and there is this, the 3 pieces, cut and paste. This is from the first one, this is from the second one, this is from the third one. 1, 2, 3. They are pasted properly. Okay. Now, how much time we have? More. Yes. Yeah. So, we will do, to brush up your computational skills. Okay. Don't feel that you cannot do, huh? Anybody having issues? Miss Chanika is also there. I'm there. We can help you. Okay. So, but you have to come for help. Come to class if you don't understand. Comment to us or send a text message. Yes. We'll give you time to meet. Okay. Now, last example for today. Example. This is the last page. Yes. Last example. Let f of x be 2x squared minus 3x plus 5. Find first one f of 0. Second one f of half. Third one f of minus 1. You have to find them. Huh? Now you can start. Then simplify. Sulkaran. Simplify. Here. 3, fourth one. F of 1 plus h. F of 2k plus 1. F of 2k plus 1. Find here h is a real number. H is a real number. K is also a real number. Find these 5 and finally simplify f of 1 plus h minus f of 2 plus h, minus f of 2 divided by h. For h not equal to 0. For h not equal to 0. Just take your time and do it. F of 0. Just put the answer 1, f of 0. If you put x equals 0, the answer is 2 times 0, 0. 3 times 2 times 0 squared. Input is 0. 0 minus 0 plus 5. So f of 0 is 5. What is f of half? Need some computation. 2 times, what is, I'll show it here. F of, how do I show? F of half. 2 times half squared minus 3 times half plus 5. Input half. So wherever you see x, you put half for that. So now this is equal to 2 times 1 over 4. Half times half is 1 over 4 minus 3 over 2 plus 5. This is half minus 3 over 2. That is minus 1. Minus 1 plus 5 is 4. So, if you are not feeling comfortable, please sharpen your computation skills. F of minus 1. 2 times minus 1 squared minus 3 times minus 1 plus 5. That is equal to minus 1 squared is minus 1 times minus 1 plus 1. 2 times 1, yes, minus 3 minus 1 plus 3 plus 5. Don't make silly mistakes. This is 2 plus 3, 5 plus 5 is 10. Plus 10. F of 1 plus h. How do you find f of 1 plus h? What is the input? Don't invent your own rules. F of 1 plus h is the output when input is 1 plus h. When input is x, output is twice input squared minus 3 times the input plus 5. So what is this one? This should be twice. Our input is 1 plus h. No? Input is 1 plus h. I'm going to write the answer here. Twice 1 plus h squared minus 3 times 1 plus h plus 5. You can simplify that. If you want, I'll leave this as a homework. You can do it the same way I do it there. 2 times, so equals 2 times 1 plus h squared. What is 1 plus h squared? 1 plus 2h plus h squared minus 3 minus 3h plus 5. Simplify. 2 plus 4h plus h squared minus 3 minus 3h plus 5. 2, 7. So h squared. Only one h squared term. H squared. This 4h minus 3h plus h. 2 minus 3 minus 1 plus 5 plus 4 then. Yes. Just to sharpen your computational skills. Okay. Do this also as a homework. Now we shall simplify this. We have 5 minutes left. This type of interesting and useful. You must be thinking from where did you pull these type of examples out. The previous ones are okay, but this f of 2 plus h. So this is what we need to find. Hope you all. What is f of x? F of x is going to be 2x squared minus 3x plus 5. Find. I need to find this now. So I need to find this. I need to find this. And then h is of course okay. Now h is non-zero. Since there is a denominator, we have told that h is not equal to 0. Now what is f of 2 plus h. 2 times, what is the input? Input is 2 plus h. Okay? Don't invent your own rules, okay? F of 2 plus h, it's not f of 2 plus f of h. F is not, this parenthesis is not multiplication. It's read f of, meaning output when input is 2 plus h. When the input is x, output is this. See the pattern? Input x. 2 times input squared minus 3 times the input plus 5. So 2 times, instead of x, we shall put 2 plus h. Where minus 3 times 2 equals to twice. Okay, here. I'll say it again. What is a plus b squared? I used it earlier, but you have to. These are important ones. All the time they pop up. Don't make silly statements like a squared plus b squared. A plus b squared is a squared plus 2 times ab, twice the product of the two terms, plus b squared. If it is minus here, middle term is minus. A plus b squared expansion. It's not equal to a squared plus b squared. How do you prove this? You look at a plus b squared equals a plus b bracket times a plus b bracket. Using distributive property of multiplication, you can multiply and get this result. If you don't know or finding it difficult to keep in memory, ask. I'll explain. Otherwise, I consider this as known to everyone. Don't forget this middle term. This is false. A plus b squared. AB squared. AB squared is equal to a squared. AB times AB, no. A squared b squared. Let's look at what happens. Here, for multiplication, it's true. If AB squared, you put a squared, b squared. But a plus b squared is not a squared plus b squared. What is true for multiplication is not true for addition. Twice here, 2 plus h squared. 2 squared is 4 plus twice the product of these two. Product of these two is 2h. When you multiply by 2 again, it becomes 4h plus last term squared, h squared. Minus 3 times 2, minus 6 minus 3h plus 5, similar to the computation I did earlier. This is equal to 8 plus 8h, distributive property. You have to multiply each term by 2. 8, first one, 8h plus 2h squared. Minus 6 minus 3h plus 5. What do we get? 8. First write down, we write the in the decreasing order of powers. What is the square term? 2h squared. Here, 2h squared, done. 8h minus 3h plus 5h. Then 8 plus 5, 13. 8 plus 5, 13. 13 minus 6 plus 7. Okay? That is f of 2 plus h. 6, 1. F of 2. What is f of 2? Put 2 there. 2 times 2 squared minus 3 times 2 plus 5. What is it? 4 times 2, 8 minus 6 plus 5. 8 minus 6 is 2 plus 5 is 7. Okay, f of 2 is 7. Now we need to find, I know this now, I know this, so just simplify. So f of 2 plus h minus f of 2 over h is equal to, here f of 2 plus h, draw the line, 2h squared plus 5h plus 7 minus 7 over h. Plus 7 minus 7 cancels. You can factor what is left. 2h squared plus 5h. If you won't write it, but you can skip this step over h. Simplify. H is common to both terms. 2h squared, so 2h. Just if you don't know, multiply out and check. That's all. 5h, you are taking h out, plus 5 over h. Okay, these are no big things, very elementary, or lab 8th grade mathematics, the simplifications. But if you are out of touch, things can you might forget them. H is not equal to 0, therefore I can cancel that to that. Since h is given to be not equal to 0. So this is equal to 2h plus 5 for h not equal. Okay? 1. That's it for today. Okay, attend the interactive sessions and if you have any issues, let me know. Just, yes, you ask for when you miss a mid-semester, quiz, students send messages. But you can send messages for asking anything difficult. If you are fine, don't worry. Just move along. Okay, but I don't want anybody to feel that these are easy, So, but we may say easy, but if you don't develop that liking to it, then it will be a very difficult road ahead, Okay, right. Shall stop there. Bye. If you have any questions, you can ask. You are welcome. Okay, if you don't have any questions, we shall leave now. Okay? Okay. You are welcome. Bye.